Welcome to my channel, Jananita. As I said, I will start the syllabus from analog electronics, which is a part of ECE, EEE and instrumentation. From this analog electronics is a basic subject which is used for all, which can be helpful in all other subjects also. So the basic foundation for analog electronics is network theory and EDC. So mostly we require most part of we use network theory. So I wanted to start in analog electronics initially. So when I talk about analog electronics, we have various devices like BJT, MOSFET, diode, Zener diode, and operational amplifier. So within the operational amplifier, I want to start the operational amplifier actually. So we know that the operational amplifier were operations and amplifier. So I want to focus on the amplifier. So the basic element, the basic application for an analog electronics, one part is amplifier. So all analog electronics is discussed, mostly focuses on designing an best amplifier. So before going to discuss about the amplifier design, we will have to focus initially about amplifier. So what is an amplifier? So amplifier is a general term we mostly heard here in the here also. So amplifier is a circuit. Amplifier is a device, one box. So amplifier is a device which is used to. So I have given a definition for any device or any application will be having a definition which describes the overall functionality of that application. So amplifier is an electronic device which is used to produce the scaled version of or increased version of, which is used to increase the amplitude of a signal waveform without changing other parameters like the frequency, phase and the shape of the waveform. So the amplifier should produce the scaled version of input signal amplitude if we say, and without changing the frequency and the phase and shape of the waveform. The shape has to increase, but the shape should remain the same of the signal. If I say that, if I represent this amplifier in a block diagram level, so this amplifier having some, I am assuming this amplifier is a device as a box, so which takes an input of 1 millivolt. I am giving a 1 millivolt of an input having a amplitude of, I am representing this input signal as a sine 1 millivolt amplitude sinusoidal wave having a time period of t. I am giving an input. I am giving as an input to an amplifier box, which is, I am assuming it as a gain having 1000. It could be 1000, 10,000. So the gain will be depends upon the design. The design requirements. So I am giving input to this amplifier and I am getting the scaled version. So V output will be K times of V input signal, which is nothing but a scaled version. Scaled version or increase the amplitude of a signal. So increasing the output. So I assume the gain of the amplifier is 1000 and also I given 1 millivolt as an input. So I am getting a 1 volt waveform as the output. So it improves the input waveform by 1000 times. So I am representing this waveform in a way. I am having a 1 volt of amplitude. So I have to observe a few things in the given amplifier that it should not change the frequency. So I have given the input having a time period of t. So it should produce also the time period of t. So the time period of the both waveforms is same. So that the frequency also same, because the frequency is inversely proportional to the time. All these are the basics. And also, so we have to focus on the phase of the signal. So both signals, the input and output are in phase. They are not leading. They are not leading. They are not lagging. They are in phase. The phase of the signal also same. So it should be the amplifier design. So it matching our definition of an amplifier. So there are in our market There are different amplifiers there, audio amplifiers there, video amplifiers there, radio amplifiers, tune amplifiers, power amplifiers, and we will have current amplifiers, voltage amplifiers. We will represent the amplifier in a block diagram way. So I will take a practical example of an amplifier. So if we take a practical example of amplifier, so I have a mic at my pocket, so which I am producing some signal. Let's say I am having some frequencies. So it could be a different frequency. I am representing this waveform in a unique form. So I am having a frequencies having 1 millivolt, let's say 2 millivolts, having a time period of, let's say, t. It is 2t, having a time period of 2t. So when I start give it is my voice signal. So this voice signal has to be given to an amplifier. It is an amplifier which produces the output. Let's say something. So this is the example which I have taken initially. So if I represent this amplifier in an electrical circuit, if I want to represent this amplifier in an electrical circuit, so let's say it is an amplifier is a box. It is an amplifier. If I want to give the input to an amplifier having a source, voltage source, let's say it is my voice signal which is in the form of electrical voice. The voice signal which is converted to an electrical form. Which having a source resistance of Rs, and it should produce a scaled version of the waveform which can be observed in the load. So load resistance, a load can be anything. It could be this section is my mic, which is so this my voice signal, the physical voice signal is converted into an electrical signal by using this device. So it is a transducer which converts. A transducer is a device which converts a physical signal into electrical signal. So this is the transducer section which gives the input to the amplifier, which amplifies my signal, which feeds to a load. The load is your mobile, whatever we are hearing the sound, which is amplified signal of my voice. This is the electrical physical representation of an amplifier. If we represent this operational amplifier, so to design an amplifier, we require at least a 3-terminal device by using the diode. So the diode is a 2-terminal device. It is a 2-terminal device. By using the 2-terminal device, we cannot design an amplifier. So to design an amplifier, we need at least 3 terminals from a device. For that, we have 3-terminal devices like BJT, FETs, it could be a MOSFET, it could be a JFET, and we will have operational amplifiers. So these are the devices which having a 3-terminal devices. By using these 3 terminals devices, this is one of the requirement. Say 3-terminal device. So another requirement to design an amplifier is that it should have dependent source. Hope you know about the dependent source. So it should possess a dependent source. It could be a voltage control voltage source, voltage control current source, current control current source, current to control voltage source. It could be anything of this voltage source. We will take one example and we will see whether dependent source circuit will give our amplifier or not. So I am considering a device having In abstract way I am taking. So I am considering a current control source having a gain of K times of V input, having a load of some Rn load. So I want to give some input to the device having a V input voltage. I want to observe the waveform, output waveform, output. So I am giving the input a voltage signal having voltage 1 volt and assume let K should be at 10. I am assuming the K gain of the system is 1. So if I apply a KCL at this node, I think you are aware of applying the KCL at any given node, because if I apply, the two currents are flowing here and there is no current flowing in this terminal because of it is an open circuited. So it is an open circuited section but there is no current flowing. So if I assume that the same current is flowing in the opposite direction, if I assume like this, so this current is flowing opposite of this current. So if I solve this equation, V out equals to minus K times of K Vi times of R load, right? So I am assuming that you are aware of applying a KCL node at a node. So V output equals to by V input is nothing but K times of R load. So I am getting the phase, it is for showing giving a phase shift of 180 degrees. So ఇక్కడ ఏంటంటే మనకి ఇన్పుట్ ఇచ్చినటువంటి వేవ్ ఫామ్ ఎక్కువగా స్కేల్డ్ వర్షన్ అనేది మనకి we got a scaled version of input with a phase change. If I draw the same signal, so I am drawing output at this place. So output is a scale. I am assuming it has 1 volt, and I am assuming the gain of the signal is 10 volts, 10. So I will get an output as, so actual it is the output we expected. So we having a 10 volts amplitude, but having a phase shift of 180 degrees, we get output as a inverted waveform having 10 volts, so minus 10 volts for the time period. Same signal we got because of having the phase shift. Some amplifiers will provide a phase shift. The common emitter amplifier will provide a phase shift of 180 degrees, where the common base amplifier will not produce any phase shift. It is a property of a device which provides. But because of providing the phase shift, we won't get any changes, because we don't have any consideration of changing in the 180 degree phase shift. So even the phase shift, 180 degree phase shift also, we will get a good waveform also. This is what I want to discuss about amplifier. If you like, please like and share, and also comment if you get any doubt, if you feel anything is not correct, and if you want to ask any question, please ask your question here in the comment box. I will answer to your questions as much as possible. And please subscribe to Jananita Adda. And in the incoming lectures, we will discuss about the operational amplifier. We will start operational amplifier. We will discuss in the first video. We will discuss about the properties of operational amplifier and the evolution of operational amplifier. So this is because I wanted to make the videos very less time duration. So that's why I end up this video now. And we will meet in the next lecture regarding the operational amplifier. Till then, bye. Have a nice day.